So today I'm going to teach you guys how to use a model set. Now this is a model set. You can buy it for about 13, well this one's about 13 bucks, and it ranges to 13 and more expensive. You can find some online, and you can make cyclohexanes, different types of molecules and all that, just to kind of give you a more visualization of what is kind of going on in front of you. So now, let's say on the test you have a question such as you have this. This is a Hallworth structure, and what you want to do is you want to label it, and this will be in the trans position. Now, what is the difference between trans and cis? Now, this is trans. Now, if this Hallworth structure was in the cis position, then it would look like this. Now, do you notice what's different and what's the same? Okay, so basically what you're looking at is the CH3 groups when we're looking for cis and trans. We have them here. So trans are kind of opposite toward each other, while cis, they're on the same side. Let's do an example. So let's bring back that Hallworth structure. So looking at this, comparing it to this, now you look at it, it's in the same shape as the Hallworth structure in a way. Now you see that you have a CH3 group, two CH3 groups, and two hydrogen groups. So looking at this side by side, we put it like this, where it's angled in the same way. So for the CH3 groups, I'm going to label them red. Okay? And then for the hydrogen groups, they're going to be white. So with that, I'm going to put my CH3 group, so line it up. Hopefully it's going to be right here. And then the other one is going to be down here because it is in the trans position. So on carbon 1, there's a CH3 and the hydrogen. So on carbon 1, there's the CH3 and the hydrogen. And on carbon 2, which is right here and right here, there is going to be hydrogen and a CH3. Now, let's look at kind of doing the ring flipped chair conformations with that. Now moving on, and what we're going to do is we are going to draw a chair conformation. So let's draw. So what I'm terrible at drawing these, but let's kind of bear with me. It's kind of after your practice at OChem and now kind of looking into it in biochem. So we're going to do, this is the first conformation you kind of want to put it in. And so with that, this is the chair conformation. So I've had this, looking back at this, I have this all the way down. I am going to put it in chair conformation. So, look at the chair conformation. This is carbon 1, and this is carbon 2. Now note this real quick. This is in axial, and this is in equatorial, and this is in axial, and this is in equatorial. Okay. Now with that being said, now we look at this, and we have it in our kind of in similarity with our Hallworth structure, so with carbon 1 and carbon 2. So what I'm going to do is when you want to transform it into both, you pull this up. Practice this also with your own model set. You pull this up, and then you pull this part down. And you want to make sure it's very, straight. You want to make sure your model set's kind of all in there correctly. But again, I'll do it one more time. Pull it up, pull down. So now notice that this carbon up here in carbon 1 is in the axial position, while the hydrogen is in the equatorial position. So what you do is you label, this is in the axial, and the hydrogen is in the equatorial position. Now looking at carbon 2, you notice that putting it in this position, the hydrogen is in an equatorial position, and the methyl group is in a axial position because it's pointed straight down. So just label that. Now let's say we're going to do the ring flip. What do we do? And this takes a little bit of practice. Looking at this now, so we're going to be looking at carbon 1 still and carbon 2. So they've put carbon 1 here with their equatorial and their axial, and then carbon 2 here with their axial and equatorial. Notice how an axial is a straight line and an equatorial is a kind of slanted. So now we have this, we have carbon 1, carbon 2 right here. Let's put it down. Now instead of bringing, so now when you do the ring flip, instead of bringing this side up first, what you're going to do is you're going to bring it down and this side up. Pull this side down and this side up. Usually I like to do up first, then down. And that kind of gives you where the, it gives you the position of carbon 1 having a CH3 in an equatorial position. So you want to put the CH3 in an equatorial and the hydrogen in an axial. And then looking at carbon 2 right here, the hydrogen is in the axial and the equatorial position is the CH3 group. Now looking at that, does, basically what's going on and what you want to do during this entire process is just taking your model set, putting, drawing out your Hayworth structure, knowing if it's trans or cis. If it was cis, it'd look like this. Knowing if it's trans or cis, and kind of going through it and saying, okay, I am now going to pull this up, this part down, and then once you do the first, chair conformation, then you want to do the ring flip, and then I would just usually flatten it down, and I know this part's going to go, instead of up, it'll go down, and this part will go up. And that will kind of give you where they're at, whether they're axial, equatorial, kind of what positions they're at, and drawing it out. Now do this, kind of take this tutorial, try it out, and see how it goes with using your model set. Kind of gives you more of a visual on the process and how it's happening. Okay, well I hope you learned something from this. Thank you so much for watching.